Now, I know there are thousands of complex electronic gadgets that dazzle with their engineering, but the design of this stuns me. I love that sound. Here's the key problem an engineer solved in designing this tab: how to make it with a minimum amount of material, but which would work every time on the billions of pop cans made every year. It looks simple, but designing it took 5 years. You see, the tabs used to be removable. I recall as a kid walking on a beach and cutting my feet. In response to this environmental hazard, an engineer designed an ingenious way to get the maximum leverage from the smallest piece of metal by making the tab change from a second to a first-class lever. Let me show you what I mean. Recall that the arrangement of 3 components, the fulcrum, the force, and the load, determines the class of a lever. A second-class lever pulls on the load in its middle with the fulcrum and force at each end. An everyday example is a wheelbarrow. In a first-class lever, the fulcrum and the load change positions, the fulcrum in the middle and the load at the end. This is like a seesaw. Now, let's look at how this applies to a tab on a pop can. The tab starts as a second-class lever where the tip of the tab is the fulcrum and the rivet the load, but then changes the moment the can vents to a first-class lever where the load now is at the tip and the fulcrum the rivet. From the side, you can see clearly how the tab, when working as a second-class lever, lifts the rivet. In fact, part of the reason this clever design works is because the pressure inside the can helps to force the rivet up, which in turn depresses the outer edge of the top until it vents the can, at which point the tab changes to a first-class lever. If you tried to simply force the scored metal section into the can using the tab as a first-class lever with the rivet as the fulcrum throughout, you'd be fighting the pressure inside the can. The tab would be enormous and expensive. I'm Bill Hammack, the engineer guy. Here.